In this video, we are going to do a comprehensive and a brief work on differentiation calculus part, and I am going to show you how we can solve almost all type of calculus questions with the help of normal formulas which we have learned, or every aspect I am going to teach you in this video. So be with me. The video is going to be very long, and you have to be with me all along if you want to understand easily all the concepts of differentiation. So let's start, friends.
Find the derivative of each function. These are very easy questions if you know a single formula of differentiation. What that is, if you are differentiating dy by dx of any function who is in the form of x to the power of n, where n is some kind of integer or any rational number or irrational number, then it is equals to n times x to the power n minus 1. Simple. So apply that here. In the first question, you can see if you are going to do the differentiation of this function, which is x to the power 7, then n value is 7. So you need to write 7 here and then x, and then as the formula suggests, 7 minus 1. 7 minus 1 is 6. So 7 times x to the power 6. That's the differentiation of this. Like that, the difficulty level will increase because we have so many of questions in this videos, all the types of questions including tangents and all. So in the second question we have x to the power 18. That's kind of easy. If you have x to the power of 18 and you do it with the same formula, then n value is 18 times x value to the exponent 18 minus 1, which is 18 times x to the power of 17. That's our answer. Let's proceed to the third one. Now in this third one, you have x with a negative half exponent. No need to worry, your n is negative half. Put it in place of n. And x's exponent negative half is subtracted with 1. And when it is subtracted, it is going to be negative 3 by 2. Correct? Because 2 needs to be taken as LCM and like that. Hope you got it. If not, put it in the comment. Question number 4. dy by dx of, let me slide it little down. We have another exercise also down. Fifth root of x. So you must know that x to the power nth root, if it is there, then it means x to the power 1 by n. Apply the same funda here. You can write this thing as x to the power 1 by 5 and apply the same. N value is 1 by 5. So 1 by 5 times x to the power 1 by 5 minus 1. How much is that? You need to take the LCM as 5. So 1 minus 5 is 4. So we going to get 1 by 5 times x to the power negative 4 by 5. You can put as a fourth root also. Now we will take up the fifth question, which is 1 upon square root of x. So let's take up the fifth question here. Dy by dx of 1 upon square root of x. You must know that another thing, like this two formulas which I am making in bracket because they are box, they are important. Same way you must know that if you have x to the power negative a, then it is can be written as 1 over x to the power a. The power can become positive if put it in the denominator, the whole thing. Same here, if you do dy by dx of 1 over x to the power half, this is can be written as half. Now you need to bring it up, x to the power negative half, and now your n is negative half. So negative half times x to the power negative half minus 1, and negative half x to the power negative 3 by 2. You can further write it in this way. It's up to you. So this one is clear. Let's go to the sixth question. Sixth question is dy by dx of fourth root of x to the power 3. Now you need to convert it by applying this nth root formula, that dy by dx x to the power 3 by 4. So the power 3 is having a denominator of 4. Why? Because it was a fourth root. Now this 3 by 4 is the complete n. So we write it as 3 by 4 times x to the power 3 by 4 minus 1. So we can say 3 by 4 x to the power minus 1 by 4. That's the answer. Or you can manipulate it as per your wishes, like 3 by 4, bring it down and create a fourth root of x, so that it becomes positive, and this way can be written for the same. Okay, let's proceed further. Find the gradient of the function for each of the following. Now gradient, slope or the differentiation, they all mean same. So we need to differentiate this. Let's do the differentiation at the corner so that we don't miss out something. Let me enlarge this. Okay. Let's proceed with red color. So if we are finding dy by dx, we need to apply the differentiation on this side also. Dy by dx of x to the power of 4 negative half x to the power 2. So we can separate it. How can we separate it? Let's check. We can write it as linear separation, like x to the power 4 is to be differentiated separately, negative dy by dx of 1 by 2 x square. You know, constant can come out in differentiation. So further we can write it as dy by dx of x to the power 4. I'm not touching this one, I'm just bringing the half outside so that you are easily able to make these two. Now individually differentiate them. So when you differentiate this part, you are going to get 4 times x to the power 4 minus 1, negative half times 2 n value, this negative 2 is there, 2 times x to the power 2 minus 1. So 4 times x to the power 3, negative, this 2 can cancel, and x2 minus 1 is just x. So this is your answer. You can further take the x common also. Hope you got it. Next one. This question can be solved with the product rule also. Let's solve this one. D of fx by dx is actually equals to d by dx of 5x times x square minus 1. You can do the opening of bracket first and then do this, or apply the product rule, but I am going by a simple way. So I am just opening the bracket. So when I open it, I get dy by dx 5x to the power 3 minus 5x. Now separate it and bring the constant out. So what we get, 5 d by dx of x cube minus 5 d by dx of x. You know x cube n value is 3, so 3 times x to the power 3 minus 1, negative 5, 1 time x to the power 1 minus 1. 1 minus 1 is 0, anything have power 0 except 0 is just 1. So, or you can simply say dy by dx of x is just 1. This is the thing you need to remember. So 15 x square negative 5. That's the answer for this. Now let's move to this one, CDF. Let's take them at the corner so that you will not get I just copy it and then we'll proceed to the next point. Okay, I am having him there. Let's select the pen. So dy by dx of fx, where this side we have dy by dx of 6x to the power 4 negative 3x square negative 10. Now we can separate them, as well as we know that the differentiation of a constant term is 0. dy by dx of any constant term without x term is 0. So let's separate it. 6 dy by dx of x to the power 4 negative 3 dy by dx of x square negative 10 dy by dx of just 1, you can say. I'm just bringing 10 out, or you can keep it in. It's up to you. We get 6 times 4 times x to the power 4 minus 1 negative 3 times 2 times x to the power 2 minus 1, and this is 0. 10 times 0, because constant term has a differentiation of 0. So let's do this multiplication. 6 4 is 24, x to the power 3 negative 3 to the 6 x to the power 1, and this is 0. So we got our answer this much. Let's solve the another question. I am solving it with different color, don't mind. Now dy by d, now x we do not have to take, because the dependent variable and independent variables are changed. Dependent variable means the variable which is depending on the some other variable. So s is the dependent variable, whereas the independent variable is now, instead of x, t, and s is the dependent variable. So we need to differentiate it. Instead of just x, you need to write the t. That's only thing you have to do in this extra. Rest all is same. Now when you apply that rule, that constant term is to be taken out and you need to differentiate by linearity property. So dy by dt of t, and differentiation of t is just 1. For this one you need to bring 2 t to the power 2 minus 1, which is, you will learn this thing, means it's very easy. You get it as 4t plus 3 answer. That's kind of easy. Let's talk about the e part. E part is dy by dt. Y is here v. So dy by dt of negative 9.8 t plus 4.9 bracket close, we need to differentiate this. So when we differentiate this, the constant part will come out and the variable part is the t plus 4.9, and differentiation of the constant term just 1 we are writing. You know, differentiation of t is just 1, so we are going to get 9.8. This part is 0. No need to write it even. So that's our answer, the differentiation of v. This is the c part, this is the d part, this is the e part. Now we will look for the f part. F part is having a dependent variable as x, but dependent variable as c, independent variable as x. So let's differentiate it. F dy by dx, instead of y we have c, is equals to differentiation of 24x plus 10. 24x plus 10. When we do that, we need to separate it, like constant term may come out and then the x is to be, and then plus 10 will come out. We are left with just 1, and constant differentiation is just 0. So, and x is just 1. So 24 is our answer for the differentiation of c with respect to x. Kind of easy. If any doubt persists, post it in the comments. Let's proceed further. The next part we are going to do here is the next exercise, which is find f dash x for each of the following function. These are kind of different type of functions. Let's take them at the corner so that I am able to explain them in a well manner. Let's check this. Let's copy and proceed downwards. Okay, I am going to paste it here. Now let's solve with a different color. Now f dash x means d of fx by dx is written as f dash x, one time differentiation. So when we do it, we get dy by dx of the 6 root over x, which we can write as 6 d by dx of root over x, and that can be written as 6 d by dx of x to the power 1 by 2. Then this 1 by 2 can be taken as n, and x to the power 1 by 2 minus half. Oh, sorry, 1. So it is 3 times x to the power negative half, and you know negative half can be written as 3 by square root of x. So that's your f dash x in this case. Let's check out the next question, the part B, changing the color. So we get f dash x, which is differentiation dy by dx of 5 fifth root of x to the power of 3. Hence 5 can come out, dy by dx, this can be written as, this fifth root can be written as 3 by 5. And when we apply the differentiation formula, which you might not be remembering, if not, let's write it here. Dy by dx of x to the power of n is equals to n times x to the power n minus 1. So apply it here, 5x to the power 3 by 5, and multiply it with 3 by 5 and minus 1. So we get 3 because 5 and 5 get cancelled. X to the power 3 by 5 minus 2 by 5. This minus can be produced in positive if you bring this down. So x square can be written like this. Hope you got it. If not, put it in the comment. Okay, let's proceed further with the C part, which says f dash, it's not negative, f dash x, which is differentiation of fx with respect to r in this case, not r, x only, as they have not mentioned it, but I suppose this r is written, but r is a constant here. Okay, so when it is a constant, we can apply the same rule here, that differentiation of any constant term is just 0. Okay, I'm just writing this constant same way, dy by dx of square root of x. So we get 0 minus 3 times half times x to the power half minus 1, which is 3 by 2 x to the power negative half, which can be written as 3 by 2 square root x. Okay, this one is quite fast, but I suppose you got this. Let's proceed to the questions of the other type. Differentiate with respect to x. These ones, which needs to be simplified. And let's copy them and solve them in a different portion here. And now I'm solving it in a portion where it is quite easy to solve here. So let's paste it and bring it this side. So I'm just enlarging this part to the 100% and selecting a different color. Now let's solve these questions of third A, and these third A questions are to be differentiated with respect to x. So f dash x, we can write f dash x. Don't write that much long divided by dx. So dx of 3 by 2 x square. This 3 by 2 is a constant, so it can come out d by dx. X square in the denominator can be written as power is the negative. So 3 by 2, n is negative 2, x to the power negative 2 minus 1. So when you do that, you are going to get this 2 get cancelled. This is negative 3 x to the power negative 3, or you can bring it down. Why not to bring it down? Negative 3 x to the power 3. That's the answer. I have created means I have not created, I just flipped it down to make the power positive. Let's solve the another question. This was A. Now I'm solving the B part. So B part, f dash x is d by dx of 3 by 2x whole square. So first solve this whole square. So when we solve this, we are going to get 3 by 4x square. 3 by 4 is a constant which can come out, and this x square in the denominator can be written as x to the power negative 2, which when differentiated with the same formula which we are doing till now is 3 by 4 negative 2 x to the power negative 2 minus 1. So this 2 get cancelled and you get 2. So negative 3 by 2 x to the power negative 3, which can be written as x cube in the denominator. Kind of easy. Hope you got it. Let's proceed with the C. C, if you find the f dash x, then you need to do the differentiation of the right part also. 4 pi, see pi is a number here, like a constant, not a variable. X is the variable, plus 3 pi. So separate them with the linear property. You are going to get d by dx of 4 pi x cube plus d by dx of 3 pi. You know the differentiation of constant term is 0. So this is going to be get off from here. And let's talk about this part. 4 pi can come out and differentiation of x cube is only to be done. So we get 4 pi x cube, 3 can come out, x to the power 3 minus 1, which is 12 pi x to the power 2 only. So this is the answer for this one. Let's proceed for the next question, D part. So D part, we have f dash x is equals to differentiation of x plus 1 to the whole square. It's up to you. You want to open this whole square first or do it together. I recommend you first open it, because as we are doing it initially and we are not applying the product rule or the chain rule. So we get d by dx of whole square formula, a plus b whole square is equal to a square plus 2ab plus b square. So 1 square is just. Now separate them. So when you separate them, you can write as d by dx of x square plus d by dx of 2x plus d by dx of 1. So constant term differentiation is just 0. So x square is 2x and 2x is just 2 because 2 can come out, x is just 1. So this is your answer. Let's talk about the next question, different color, which is E. This was D and now we are solving E. So f dash x is equals to d by dx of x cube plus x minus 3 over x, and when you separate the denominator from all of them, you are going to get d by dx of x square plus 1 minus 3 by x. Now separated with the linear property, you are going to get d by dx of x square plus d by dx of 1 minus 3 d by dx of c. X in the denominator can be written as x to the power negative 1. Okay, and when you do that, x square, this is constant term, so going to be 0. So x square is just 2x because 2 is the n, x to the power 2 minus 1 is just 1. Negative 3, negative 1 can come out, and x to the power negative 1 minus 1, which is 2x. Negative 3 when multiplied with negative 1, it's going to be positive 3, x to the power negative 2, and this 2 can become positive if it goes in the denominator. Like further, if you want to answer it in the same way, you can take the same x square as the denominator and write it as 2x cube plus 3. Hope you got it. If not, put it in the comment so that I can understand where are your doubts. Okay, let's talk about the F part. Let me change the color here. Oh, I selected the same color again. Okay. F part. F dash of x is equals to d by dx of 2x minus 1 times x square plus 3. Now what I recommend is first you open the bracket and apply the linear property. So when you open the bracket, what you are going to get? 2x cube plus 3 to the 6 x square, only x, negative x square, and this one as negative 3. So now you can see further simplification is not possible, only arrangement is possible, and we can separate them by the applying the linear property. So we get x cube plus 6 d by dx of x negative x square. So d by dx of x square minus d by dx of just 3, and 3 is a constant, so it is going to be 0. No need to worry about it. What about this? 2 times n value is 3, 3 times x value 3 minus 1 plus 6. This is going to be just 1, negative 2 x to the power 1. 2 minus 1 you can write if you want to, 6x square plus 6 plus minus 2x. Arrange it, you get f dash of x is equals to 6x square minus 2x plus 6. That's the answer. Hope you done it like this one. Proceed further. Okay, this one we have done. Now the part we have to do is this square root of kind of thing. Let's copy this one also. When you copy this one, you just need to put a selection like this, and here press the copy and take it at the corner, put it little down, and then paste it. Done. Let's do this. Now in this dy by dx of y is to be done, so applying dy by dx on both sides, Difference of this type of question is that here you need to converge these two, means x in the root can be written as x to the power 1 by 2. So let me solve it here at the corner. X times square root of x. You know x is having power 1, square root of x can be written as 1 by 2. When the bases are same and they are in multiply, power is to be added. So 1 plus 1 by 2 is x is equals to 3 by 2. So when you do this, you get we separated, like 1 is to be separated, plus dy by dx of x to the power 3 by 2 is separated. 1 is a constant, no need to worry, it's going to be 0. What about this? N value is 3 by 2, so n comes out x to the power 3 by 2 minus 1, and you know it is 1 by 2 only left, so x 1 by 2, and 1 by 2 is just square root of x. So that's the dy by dx value for this one. That's the A part. And this one is just the observation which I have written. Okay, for this. Let's solve some other question. B part here. So B part, dy by dx of this right side we have 7 by x square minus 1 upon square root of x. Separate it. When you do the separation, you get 7 out, dy by dx. X square can be written as negative 2 when it comes in the numerator part. Negative dy by dx. The square root of x is x to the power 1 by 2. But when it comes on the top, it's negative 1 by 2. Okay. So now we proceed with the differentiation. X to the minus 2 will come out because n value is negative 2. X times negative 2 minus 1, negative half, because n value here is negative half. X to the power negative half minus 1. Solve it. Negative 14, because 7 to the 14 and negative symbol. X to the power negative 3, negative is positive. Positive 1 by 2, x to the power negative 3 by 2. Let's write them in the denominator so that the power becomes positive. So plus 1 by 2, x to the power 3 by 2. There are other ways of writing this also, but almost all are same looking, but they are equivalent. Let's talk about the other question, the C part, the last question of this part or this exercise, I suppose. Changing the color, which I always want to do. Sorry if you don't like. C. Dy by dx of the right side which we have is cube root of x plus fourth root of x. Now you know how to separate them. Dy by dx, x to the power root, nth root. I have written it here also, that x to the power n. If it is in the denominator, then it means it is the nth root of x. Same here, it is third root, so 1 by 3 plus dy by dx of x to the power 1 by 4. Here n value is 1 by 3, so you know how to deal with that. N 1 by 3 will come out, times x to the power 1 by 3 minus 1 plus 1 by 4 is the n value, x to the power. This everything which I am writing, it is in the power. Now when you solve this, you are going to get 1 by 3 x to the power negative 2 by 3 plus 1 by 4 x to the power negative 3 by 4. Further, you can write it in the denominator or the root values like cube root of x square plus 1 by 4 fourth root of x cube. This is another way of writing this. Because negative means you need to flip it down in the denominator to make the power positive. Hope you got it. Let's proceed further with different type of questions. And this all are done. F. Find the gradient of the tangent to each function at a given value of x. Now we need to find the gradient of these these functions at a point. Means the value of x is fixed. See, the differentiation is done at a point. So let's solve the first one. Y dash is another way of writing dy by dx if you don't know. So it is dy by dx of x square minus 4x plus 2. Separate it, you get 2 dy by dx of x square negative 4 dy by dx of x plus dy by dx of just 2. So you get 2 x square 2 times x to the power 1 minus 4 times 1, this is constant, so 0. So you get 4x minus 4, that is your y dash. But now you need it at x to the power x value as negative 1. So what you need to do is you need to put in place of x negative 1. What you are going to get negative 4, and that's negative 8. So answer for this one is negative 8 answer. Like that way you will do for this. The y value is not that important, but x value is, because you need to substitute it in that part. Solve for the differentiation of b and c part and substitute x is equals to 1, x is equals to 1. Whatever value of y dash you are going to get, that is the gradient of the tangent at that point. Now find the coordinate of the point on the graph, this where the gradient is 2. So you need to find its gradient first, f dash x, which is, let me solve it quickly. 2 by 3, x cube is 3x square, negative 9 by 2, x square differentiation is just 2x, negative 3, 8 is just constant, 2 cancel, 3 cancel, we got this. Now the gradient is equals to 2. So what is the value? So 2x square negative 9x negative 3 is just equals to 2, and we need to find the value of x. How to solve that? It's kind of easy because it is a quadratic equation, but bring everything one side. So when you bring it this side, you get 2x square negative 9x negative 5 is equals to 0, and you know we can solve it as 10 and 1. So negative 10x positive x negative 5 is equals to 0. 2x can be taken common, x minus 5 plus 1 is taken common, x minus 5. So we get 2x plus 1 and x minus 5. So 2x plus 1 is equals to 0, which means x is negative half, and x minus 5 is equals to 0, which means x is equals to 5. So these are the 2 points where the gradient is 2. Kind of easy, but you need to be cautious while solving. Hope you are getting this. Let me solve these other questions in the other video, because there are so many questions and the video is too long. Let's stop here, and don't forget to share it and subscribe it. See you. Bye.